Hi, folks. My name's Tony Denby, for those of you who don't know me. I had the pleasure of being treated at Loma Linda in 2008, and been out there a few times to tell some jokes and stories. And I picked Monday as a day for this presentation because I figured all the golfers would come. What I didn't know is that the golfers use Monday to make their medical appointments. I can't believe how many people I spoke to who said, sorry, but I have 3 appointments in Charleston or wherever. And I figured out the golfers don't want to win golf trophies anymore. What they're really after is getting a handicap play to the golf course. So anyway, well, maybe at the end I'll tell you a long, funny story of how I got to choose Loma Linda, California, because I was living in Germany most of my life, my business life. I still live in Germany. I've been there since 1968. And I managed to find Loma Linda through some very incredible circumstances. It worked out, you know, radiation vacation, maybe what I am today. So, without telling too many stories, because I know you're more interested in what these wonderful people have to present, and the reason for this is just being able to give you some knowledge. Education is everything. Being able to pass the word on about what's going on is really great, to be able to put something like this together. So, without any further ado, I'd like Rochelle to come up. She's going to introduce all the people. Michelle is a super registered nurse, which she's more proud of than anything else. Michelle, and she picked up a friend.
Absolutely. Thank you so much, Tony. And, you know, it is such a privilege to be here with you. I was actually born in Greenville, South Carolina, lived in Lexington and down in Hilton Head in this area for many, many years, and it is like coming home. So thank you for the warm Southern hospitality. We're so honored to be here today. I just want to introduce, I'm Rochelle Vassell. I'm Senior Vice President for Advancement at Loma Linda, and have been there for 13 years and have just really, really loved the experience. And Randy Possinger, over here against the wall, is our Assistant Vice President for Advancement and Philanthropy, and has been with the institution 1 week longer than me, so he says he's my senior. I'll give it that. But anyway, he's from North Carolina, so again, it's coming home from the West Coast to here, so again, it's a real privilege. But I want to introduce to you Dr. Reeves this morning. Dr. Reeves is an incredible individual. You will find that out here shortly. He went to medical school in Loma Linda, and then did his residency and went to Memorial Sloan Kettering in New York for oncology, as well in his fellowship with the NCI National Cancer Institute in surgical oncology. He is board certified surgeon, and he has done many other things. He's also gotten a PhD in biochemistry from UCLA, and he's a fellow with the American College of Surgeons, as well as a fellow society in surgical oncology. I can tell you that if you look him up on the Loma Linda website, you know how you have patients that do ratings. There are 5 possible stars. He has 5 out of 5 possible stars because he is an incredible physician. You'll hear from him this morning, but I can tell you he's also my husband's and my mother-in-law's a physician as well, and he is an incredible caregiver. So you will learn a lot this morning, and he is probably one of the most caring, genuine physicians that I've had the privilege to work with. And so it's my privilege to introduce to you Dr. Mark Reeves.
Thank you, Rochelle. You know that you should only believe a part of what you hear when people are introducing people.
Not true.
All right, I'm really tremendously honored to be here. I'm amazed that there are this many people that are interested in learning about cancer. In the morning when you look out the window and you see what's out there, I know they're not open to do golfing today, but I really appreciate it. I know that there are better things that you could be doing on a Monday morning. But this is something that means an enormous amount to me. I was telling some of you earlier, I've been in the field of oncology for about 30 years. And so I've taken care of thousands, literally thousands of patients with cancer. And actually, the stories that they have. I met some of you this morning that have amazing stories about your progress through cancer treatment, and it's not always easy. Sometimes it's a journey that really has an enormous amount of work associated with that. But there are some things that are happening that I've seen now over my 30 years in this field that I think this field is really on the kind of the cusp of turning in a new direction. That's actually already started. I'll just tell you a couple of things. When we look back to 30 years ago, we've actually seen that the death rate from cancer is going down. There's no question about that. The problem is that there are more and more new cases. And so there's still a tremendous number of people that are not winning their battle with cancer, but it is very clear, 25% lower death rate in the last 30 years from cancer. That's amazing to have a disease as devastating as cancer with the death rate going down like that. But I want to talk to you now about some treatment approaches that we're implementing, certainly at Loma Linda and in other places, that I think are going to be changing the way that cancer is both diagnosed and taken care of. So, okay, let's see, maybe it needs to just be unfrozen, right? Sure. Yeah, that's right. They got lazy.
They started looking outside.
Yeah. All right. So what I want to do is I want to talk to you about 3 specific types of targeted therapy. And again, the key here is the targeting. And that's a new approach to cancer, where it used to be kind of a haphazard thing where you just kill cells and hope that the cancer dies. These are called cell therapy, theranostics, and I'm going to use the term BNCT. It stands for Boron Neutron Capture Therapy. Don't worry about that, we'll learn about that, but BNCT, so cell therapy, theranostics, and BNCT. I want to start by talking about a type of therapy. It was interesting, I was talking earlier about a targeted type of cell therapy called CAR T therapy. And it's actually a treatment that really just takes a patient's own cells, you take them out of the body, you put a new receptor into those cells that is directed against their cancer. So you study their cancer, you say, I know what would make them attack that. You genetically modify that, and you put them back into the patient. And so that's kind of schematically diagrammed here, but the thing that to me is amazing about this is that, so this started in children's leukemia. So most patients actually that get leukemia as a child, they can actually be cured with chemotherapy. It's hard treatment, but about 2/3 of them will be cured. The problem is that 1/3 that relapses, in the past, 100% of those patients are going to go on to die of their cancer. This is a type of an approach that I worked on this as a fellow at the NCI. And back then, this was about 30 years ago, wasn't really thought to be amounting to much. The field has progressed, and now, for children's leukemia, even the ones who have relapsed, and the patients are now on hospice, with nothing more to do, one infusion can actually cure the vast majority of these patients. That's an amazing thing. It's taking a kind of what we call an incremental approach to cancer treatment, and it just completely blows that out of the water and says this is revolutionizing the way that we do this. Another type of cell therapy called TIL therapy. So this is similar. What you do is you take a patient's cancer. There are some of their T cells, those same cells that we use for CAR T, where the patient's own T cells have already figured out how to attack their cancer. And you can actually find those cells within the tumor. So you take the tumor out, that's diagrammed over here, and within those, there are a small number of cells. They have the right receptors. They can get there, they can destroy the cancer, but there aren't enough of them, and they're not active. So what you do then is you take those out in the laboratory, you activate them, grow them to large numbers, you infuse them back into the patient, and it is amazing. I actually have patients from 30 years ago when I was at the NCI that were treated with widely metastatic cancer that are still alive without evidence of disease. Now the problem is that not enough patients have that type of a response where they're cured. But, again, this was initially thought like this isn't going to really go anywhere. Just 2 weeks ago, the FDA approved the first TIL therapy for standard of care treatment of widely metastatic cancer. It's never happened before. And the reason is because the advances in how you grow and stimulate cells has completely changed. And it makes TIL therapy now an option for treating cancer in the mainstream. And then, in addition to that, there are a number of other benefits from cell therapy programs outside the field of cancer. There are many diseases that can be treated with gene therapy, where you take a patient's cells out. An example might be sickle cell disease. So it's not a cancer, but their hemoglobin that carries oxygen, it's not right. You can actually remove the gene for that from their cells, put the correct one in, give them their cells back, and then cured of sickle cell disease. That's really just an amazing thing if you think about it. You can also do stem cell therapies. So you've probably heard about these for treating heart disease, etc. So non-cancer treatments. And of course you can do cell transplants using this also. So typical quote-unquote stem cell transplants. So at Loma Linda we've created a cell therapy program where we've taken a novel approach to this. Most places that develop cell therapy programs, they have one for kids, one for adults. We've actually created a single therapy program that goes across adults and children. And it has had really a transformational effect. We, just a couple of weeks ago, we did at the same time CAR T therapies on an adult and a child on the same day by the same team. And it's quite revolutionary to do this. The other thing is that we have developed a laboratory at Loma Linda that is allowing us to create these new cell therapies. But then we have what's called a GMP cell therapy lab where we can actually manufacture these as actual treatments. So you do the experiments in the lab using mice and that kind of thing. You say, hey, this looks like it could actually work. Using this GMP lab that we're building, you can then take that exact receptor and now make it a human product, actually. So it's a taking it from animal studies and now making it a human treatment right on our own campus, not waiting to see, is a pharmaceutical company going to get interested in this, that kind of thing. You can actually open a clinical trial and do it immediately. So I'll just tell you a little bit about this. I'm very proud of it. It allows us to do a fully translational approach to cell therapy. As I said, you can manufacture experimental cell therapies. It's about a 6,000 square foot facility, and we're finishing it at the end of this year. It's already started construction. So I'm very optimistic about where cell therapies is taking the field of cancer. I want to move now to another therapy that to me is equally compelling to cell therapy, and in fact, in some ways, more so. Randy's going to play a video that explains this, and then I'll talk a little bit more about it.
Therapies is not a common word. It's actually a mix of two words, therapy and diagnosis. The diagnosis comes first. Then we add therapy for a treatment that helps improve lives. Some tumors, such as advanced prostate cancer, are difficult to treat and can even resist treatment. So we use diagnostics. It works a bit like mailing package. When we examine prostate cancer patients, we may see high levels of the PSMA protein on the surface of their cancer cells. High PSMA acts like an address. To confirm the address, we inject our diagnostic molecules to locate the cancer cells. With the address confirmed, we inject more of our molecules, but this time with a surprise package, cancer-killing radiation. Our molecules arrive and the PSMA proteins invite them in. Then, our molecules attach themselves to these proteins and deliver their hidden radiation payload. This targeting destroys cancer cells without damaging healthy tissue, all helping to minimize side effects. That's diagnostics, an uncommon word for an uncommonly effective treatment.
All right, thank you, Randy. So I just want to reiterate then, theranostics then is a process where you have a molecule that binds to a particular type of cancer. And in one instance, you put an atom on it that you can actually image. You can see it. You can think of it as similar to what is called a PET CT scan. You can actually do a scan of a patient. You can see everywhere in their body. And I'm going to show you a picture of this in a minute. You can see everywhere in their body where there's cancer. Then you know that it binds to the cancer. Instead, then you just take that atom off that allows you to see it, and in its place, you put an atom that delivers a killing dose of radiation. So then that molecule goes to the cancer and it destroys whatever it binds to. Now it sounds simple, but this actually, if you think about it, it's quite amazing. And I'll show you what I mean by that. So again, you image kind of where is the cancer, and you have the answer to the question. You know for sure that it binds this molecule. And then because of that, you can use it to treat the cancer using that same molecule. So think about this then. This is the ultimate form of personalized medicine. You can use molecular imaging to answer the question, does this drug actually work for the cancer that's in your body? Not just we take a drug and we think it'll treat most patients with this kind of, let's say, prostate cancer. You can actually look at the scan and you know for sure that it will actually bind to it. You can know how much disease you have. You can actually, unfortunately, in cancer, sometimes cancers will become resistant to drugs. With this, you can actually see that by doing a scan. You can know that the cancer is no longer binding that molecule, so there's no reason to go on using that same drug. You need to switch to something else. Instead of the usual approach is, well, you have to wait until you see tumor markers going up or, cancer is getting larger on the CT scans. Now you can use this molecular imaging and you can say, okay, this cancer has now changed tactics. It's not binding this anymore. Let's stop using this. And then likewise, based on this imaging result, you can actually treat with a molecule that you know confidently will bind to this cancer and actually treat it. There's no more guessing if the therapies are going to work. And then, again, you can move to another type of therapy if the imaging is no longer showing binding. So, let me just show you an example of this. This is actually these are actual scans of PSMA imaging. This is a patient that actually was, he had a negative traditional CT scan. Couldn't see any disease anywhere. But his PSA was very high, so you know there's disease. Then the PSMA scan was done. You can see that there's disease, all of these black spots everywhere. There's diffuse disease everywhere. So, using PSMA-based therapy, where you now hook a radiation molecule onto that PSMA, successive treatments with actinium-based PSMA, and then again, you can see that now there actually is no further disease, and the PSA has now become undetectable. This patient on the left had already been treated extensively. He had kind of exhausted everything else there was to be had and was actually put in hospice. Now, no disease. That's just amazing. It's a completely revolutionary thing that just overthrows everything that we've always learned about cancer treatment. Kind of go down that path of treatments until there is no more. And this is completely disrupting that. So similar then, we're in the process of building a theranostics program, similar to what I described for the cell therapy program, that allows us to have both theranostics and imaging clinics in the same place. We have cyclotrons there. This is an important part of this. A cyclotron is a machine that will actually generate both the imaging atom and the treatment atom. And so what this allows us to do is, just like with the cell therapy lab, it allows us to just generate these new molecules that we find. So for instance, we have a group who does nothing but look for new molecules that will bind to cancer. So for instance, prostate cancer. Most prostate cancers will bind PSMA, but not all do. They have found a molecule that non-PSMA prostate cancers will bind to. So then what you do is you use that to develop that same approach. That drug is, or that molecule is called enolase. The name doesn't matter. But then you can do the exact same thing where you use enolase imaging and then treatment to get the same type of an approach. And with this theranostics center that we're building, you can actually quickly move those kinds of results from the lab into patient treatment using clinical trials, even before they're approved by the FDA. And again, you don't have to worry about whether a pharmaceutical company thinks it's going to make enough money to develop it or not. I want to finish talking to you about a last type of targeted therapy. It's the third of the three. So we've talked about cell therapy, we've talked about theranostics, and now we're going to talk about BNCT. Remember, this stands for boron neutron capture therapy. Both BNCT and proton, so that was actually the way that Tony was treated at Loma Linda. These are both particle therapies. What that means is that both neutrons and protons are actually particles that are used to treat cancer in a very, very targeted way. And they actually have a lot of similarities. We're actually building a BNCT facility where we are on a track to become the first place in the United States with a BNCT center. And I'm going to describe to you what this means, but it's another of these targeted approaches that we think has enormous potential to completely disrupt the way that cancer has been treated. So it's a precision medicine approach to destroy cancer cells while leaving the surrounding healthy cells unharmed. So here's how it works. So first of all, you give a patient a drug that has two things. Number one, it has boron in it. And two, it has a targeting mechanism that will take it only to cancer cells. So you give this drug, and actually boron by itself has no toxicity. It's fine. You can infuse that, it will go into cancer cells. It won't do anything to them at all. But then what you do is you then irradiate the tumor site with what are called safe neutrons. The scientific word is called epithermal neutrons. And again, these neutrons by themselves, they don't do anything at all to you. But the key is that when boron interacts with these neutrons, the boron disintegrates, breaks into half, it leaves a lithium, and it makes an alpha particle that again has destructive radiation, but only for a very short space around it. So essentially what happens then is that every cell that has boron in it, in that neutron field, those cancer cells will be destroyed, but the surrounding cells that have not taken up the boron, they will do just fine. So, give you the sense, this is a very, very targeted approach to treating cancer. So, there is BNCT available in a very, very small number of places. In some countries, most of these are experimental programs where they have started to do some work in cancer treatment, but there's none in the United States. But there is some data from both, I'll give you two examples, but one is in recurrent head and neck cancers, and another is in a brain tumor called GBM. The reason those were chosen is because these are particularly difficult cancers to treat. So in recurrent head and neck cancers, these are patients who have exhausted every treatment. They've already gotten maximal radiation, they've gotten chemotherapy, it's no longer working. In that situation, you would expect about a 5 to 10% response in those patients if you had an effective therapy. Most of those people are going to be in palliative care. BNCT has consistently shown a response rate of 70% in those patients. It's just unheard of. Again, you expect really no response. Here, the vast majority of people getting a response to it. Similar experience in GBM. And so we're working with a number of different companies. These are large, many of them engineering consortia that are interested in helping to establish BNCT as an actual treatment modality that patients can receive in the United States. We've worked with them. It'll take a few years. It'll take 3, 4, 5 years for this, even with really good results coming from clinical trials to become FDA approved. But the point is that you can actually deliver BNCT as a treatment even before FDA approval comes by using clinical trials. So you can make these treatments available in the run-up phase before FDA approval. This of the three treatments is the farthest one on the horizon. It's less well developed. Kind of to look at the three cell therapies the most, we're actually already doing it. We're just expanding into very experimental ways of doing it. Theranostics, very young, but we're doing that. VNCT, nobody in the US is doing it yet. So I'm going to finish there, and then I'm hoping that some of you will have questions. I just want to say then that we're kind of investing resources in what I call disruptive cancer therapies. So they're targeted, highly personalized. I think the message from all of these is that these, and even in very hard to treat cancers, have had very, very high response rates that you just don't expect when I use the word disruptive. So again, theranostic cell therapy and VNCT. I want to close by making a comment here. It's interesting that Loma Linda actually was chosen by several of these companies to do the first VNCT program, primarily because of the work that we originally did back in the 90s to develop proton therapy. So Loma Linda was the first place in the world that had a clinical hospital-based proton therapy unit. And we were the only ones for about 15 years. There was one at Mass General where they treated a small number of patients. But so over those years and up until now, we just celebrate our 30th anniversary of that. We've treated thousands of patients with proton therapy. So we have a good experience with that. It's not lost on me that experience is very, very synergistic with some of these. So I want to give you an example. I would actually argue that we're probably the only place that can answer some treatment approaches, for instance, that combine proton with theranostics. What if you had a patient who had prostate cancer? Most of their disease is in the prostate, and so they'd be a perfect candidate for proton therapy. But you do a PSMA scan, you find out that they actually have a little bit of disease outside of the prostate. What if in that case, the approach, instead of what we do now, we would do surgery or we would do proton therapy or something only, and then maybe use hormone suppression with its side effects, and it may or may not get rid of all the disease. What if in that case you actually do a clinical trial that combines using PSMA theranostics together with proton therapy? It's actually a very compelling thing. What if you combine VNCT with theranostics? So remember, one of the things that is key to doing VNCT successfully is you have to get the boron inside of the cell. Well, if you have molecular imaging that's part of theranostics and you actually use that then to answer the question, is that boron inside of the cell? You can be very, very effective at doing VNCT. You can develop the drugs to do that. Same thing for cell therapy with theranostics. Both of these require molecules that are very specific to the cancer. You could actually develop both theranostic techniques and cell therapy techniques and maybe even use them together for particularly hard to treat cancers. But unless you have all of these programs kind of in one place, you're not going to even ask those questions, much less answer them. And so I'm very optimistic that this type of an approach where you bring together targeted approaches to treat cancer all in one place, that's what will give the answers in the future that make even these targeted therapies far, far more powerful. And that's why even after 30 years of treating cancer, I'm very optimistic about where this field is headed to. There are so many tools that can be used. Now they just need to be developed. So anyway, I want to stop there, and I really want to thank all of you for your attention and the time that you've given today. And if any of you have any questions, I'll be happy to answer them. Yes, I'll start. Tony, yes, please.
And these have not been pre-prepared questions. I just put my auditor's hat on and I wrote down 4 questions.
Good.
If you've had previous radiation, can you still have additional radiation with this boron and theranostic treatment? That's one. Then I put my cost hat on.
All right.
And I said,
I like it.
who's going to pay for this stuff?
Yes.
Because in my case, all the people at Loma Linda that we encountered in all of the groups and in the sessions, they all had problems getting payment from their insurance companies.
Absolutely.
And there's so much resistance still within the U.S. system today
Yep.
to discourage you from getting PSA tests, which to me is ridiculous,
Yeah.
and then to try and refer you to more traditional treatments for prostate cancer. And the last question is...
Now you're going to ask all these questions, and I'm going to forget.
Oh, I'll repeat that for you. I'll just, you'll read it. I know you already. And the drug to develop and to bring the boron, to deliver it to the sites. Those are the 4 points. You won't make notes.
No.
Okay, so let's do them. Let's see, which one should we take first?
Previous radiation.
Perfect. Previous radiation. So I want to take the answer to your question is absolutely you can. And here's, that to me was just an eye-opener. Because these patients with recurrent head and neck cancer, they have been radiated to some of the highest doses that you can deliver. Because the head and neck structures will actually tolerate a fair amount. There's no intestines nearby, but it has side effects. I mean, it makes it so that your mouth doesn't make saliva and that kind of thing. So there are big problems with it, but you can deliver very high doses. In fact, to the point that if you deliver additional radiation in that setting, many of these patients will get what's called osteonecrosis, or their jaw will actually fall apart because the cumulative effect of all of that radiation. So we know in conventional oncology, once somebody has received that kind of a dose for head and neck cancer, you can't radiate anymore. But it's in those patients, those exact ones, the 70% response rate. And the reason is because the boron neutron capture therapy is delivering radiation at the molecular level. It's not delivering it grossly to a big field. And so yes, you can absolutely give BNCT after a patient has completely exhausted a radiation dose that would be considered safe. Now, nobody's going to be cavalier about this, but that is an unheard of thing. Usually in oncology, when someone's had that much radiation, it's all done. There's not going to be any more radiation delivered. Second one was cost. Perfect. So actually, as you said, Loma Linda has had an enormous experience with this because of proton therapy. You're right that still proton therapy has some resistance to being treated, but actually I would say that in reality probably 85–90% of that has gone away because it has now developed a track record where it's not considered quote-unquote experimental. But you know that insurance companies are always looking for excuses why they cannot pay for something. In some of these therapies, and we've already started to take that approach in cell therapy. This is a good example. The cell therapies are very expensive. However, if you compare the cost of a single infusion of cell therapy, which can actually cure patients even after they have exhausted conventional treatment, what is the cost of a single infusion of cell therapy compared to years of giving chemotherapy drugs to patients, along with the testing and the scans and all of that goes along with it? There are actually trials underway now that look not only at the outcome or the cure rate, but what is the actual cost? And it's looking like those approaches that have single high-cost components to them that are highly successful are actually cheaper in the long run. Now, none of us was born yesterday. The U.S. economy, healthcare interaction is very complex, and people can move from one, insurance to another, and insurance companies are always wanting to put that on somebody else. But as you start to develop, quote-unquote, trial evidence that shows that these high-cost single treatment therapies are actually overall cheaper, that's what will change the mind of insurance companies to actually pay for those. What was the last one?
There wasn't less than 2 more. What would you cut? Yeah, but the drug to develop Boron.
Yep. So we actually have two scientists at Loma Linda they're boron chemists. That's actually all they do. We recruited them to help build this BNCT center. And one of them, he was in a completely different field. He wasn't in the field of BNCT, but he's an expert, has become that over a couple of decades in kind of how can he do the chemistry of putting boron atoms onto a molecule. Well, when I saw him, available and said, hey, we're building a BNCT center, we need you to come here. And so he's here doing that work for us. And so I have as Rochelle said, I have a PhD in biochemistry, so I understand some of it, but boron chemistry is very complicated. This guy's an amazing person. He can do these syntheses, and he's drawn out the pathways for how he can do this, and he can actually put boron onto almost any molecule. So if other people developing molecules that are binding to a particular cancer, and then he takes that and develops a synthesis pathway that will put boron into that. So it's kind of a custom developed approach, if you will. That's going to take time to experimentally show that those are going to be effective, mainstream practice. But again, to me, that type of a rationale, that's how you do it. You do it with a very, very targeted approach. Yeah. Other questions? Yes, please.
You seem to be, I don't need that.
Okay.
I've been teaching.
Yes, you do. Please talk in the mic, because we can't hear you.
I'll talk loudly. Okay, anyway. The things we talked about here, the proton, the theranostic, and the BNCT. I was involved a little bit with cancer development for pancreatic cancer way back when. And we had to go through stages. What stage are you at with this situation right now? And the other part of that is, how much resistance are you getting from pharma?
All right, great questions. So actually, we're at different stages on all of these. So the cell therapy program, we've built most of that. And we're going to open the lab this year. It's already started construction. Theranostics, we're doing theranostics, but we don't have the kind of the experimental capabilities of that. There are only 2 drugs that are really available to treat patients theranostically in the United States. As you can see with those kinds of results, there need to be 40 or 50 of those drugs, and there will be. The point is that we're trying to position ourselves to be able to develop those. We're not going to wait until those show up, because you asked the question lastly, what kind of resistance are you getting from pharmaceutical companies? We're actually not getting resistance. That's usually not what pharmaceutical companies do. But what they typically do is when you develop something that is compelling, most of the time they'll just end up buying it and they'll license it and that kind of thing. However, there are examples where if they have a competing drug, they will buy it and then not develop it. Right. And so that's kind of a cynical approach. We actually have people at Loma Linda that are experts in what's called technology transfer. They're lawyers who have the experience in the biomedical field. Typically, they will be doctors or scientists who also have a law degree, kind of on our side, looking out for things like that. But you're right, it's not a trivial point, because this is a big, this is an industry where there's a lot of money that can be made. I would argue that how much money you make is shouldn't be the purpose of what we're doing this for. This is for helping patients with cancer.
Right. The situation with the company was called Supergen, and stage 1 was very successful. Stage 2 was even more successful. Then all of a sudden, there was talk of Amgen buying Supergen, and all of a sudden, stage 3 was not so good.
Yeah,
So,
yeah, understood. Point well taken.
I don't need the mic, this is real quick. You mentioned there's only 2 facilities offering theranostics.
No, there are more than 2 facilities offering theranostics. There are only 2 drugs available in the United States now for treating theranostics.
That's what the question was. Has the FDA approved PSMA therapy yet?
Yes, it has. However, when did it happen? It happened 6 months or so ago.
All right, thank you.
But it's not as simple as that. Now the FDA has approved it. Novartis, which holds the patent on the drug for treating with prostate cancer PSMA, it's called Pluvicto. They have had manufacturing problems that have tremendously delayed the amount. So very few people have actually been treated with PSMA therapy. Eventually that will be solved. But if you think about with those kinds of results, prostate cancer is a very, very common cancer in the United States. There are millions of patients who would benefit from PSMA. Eventually, those patients may have the opportunity to get treated, but there's an entire infrastructure that isn't even present here to do that at that kind of a scale. And again, that's kind of partly why we're doing what we're doing. But that's an excellent question. But yes, approved by the FDA, but difficult to actually get access a lot of times to the drug still.
You can always go to Australia or Germany.
Yes, Germany. Germany is actually the place where, yes. Please, let me.
I'm interested in the patient
Here.
experience. I'm interested in knowing about the patient experience in your clinical trials and assessment to qualify when they come in and your demographic. And I know it's challenging to even know that you have clinical trials. So give me the patient walkthrough.
I will. So maybe I'll do this from the standpoint. It was about 2 weeks ago. I was at an event where we celebrated a story of a child who had been treated, looks like now, successfully for leukemia. So it's kind of a poster child. She had a very, very difficult time. Her story was told over about a 3-year period. She spent probably, in reality, when you look at it, most of her time in the hospital. That's not a good way to grow up as a child. Every time you see a person with a white coat on, or you just, Then, so same patients in a cell therapy trial, single infusion, no longer spending their life in the hospital. So that's the first part, is that when you have these disruptive type therapies, even though the process of going through a clinical trial is burdensome, many times the actual in totality of that with these types of agents turns out to be much, much better than going through the conventional process. Yeah, no, it really is, especially for children. So we have a clinical trials unit in the Cancer Center that specializes in these types of clinical trials. It's actually a separate unit from the rest of the institution, primarily because these trials are hard to do And they require a lot of both expertise, but then, as you said, just getting the word out that trials are available. Probably the best partner on that has been the NCI. They have a website that we register all of the clinical trials at so that patients can search that. But the problem is that even those are hard, and most of the time it requires a physician to kind of interpret which ones would you really be a candidate for. But we go through that process so that patients outside of the institution can know what are available also. That's a very good question because it is a real, it's a hard thing to go both through cancer therapy and also go through the clinical trial process.
I think it's difficult for professionals that work in the field to even manage to do that.
Yeah.
You have, I'm sure you get 1-800 calls all the time.
Do.
How do I get to this person?
Yes.
How do I get to that person?
Yes.
I mean, that's the real struggle.
Yes, absolutely.
To do the work you're doing.
Yes.
Congratulations on the work.
Sure.
Thank you, and thank you for your presentation. The three programs that you mentioned and so forth, it just seems to me like there's a lot of other work going on around the United States and Germany and other places. I mean, you got the place down in Houston, you got Cleveland, you got Duke, you got Dana-Farber, you go on and on and on here. And this country is so rich in resources. I'm just thinking, and I'm a cancer survivor, incidentally. I had prostate cancer 23 years ago and was fortunate to get treated. But the, why is it there's a central, we put a man on the moon back in 1968. And we got a lot of energy here in this country, a lot of bright people. It seems like it should be someone like Elon Musk in control or something, and it all comes together in one place where you have the brightest minds and scientists and everybody else working on this thing, and we got $1 trillion is nothing to us now. We could pour it into it, and we should be able to develop these things quicker than I'm talking about. I almost wish the President of the United States would step in on this and really pull this all together. There's a lot of people here suffering because of cancer that I think really could be treated if it was centralized. I'm talking about the resources, the energy, and the people. We have it, and we're not doing it. My last point on this, I was just wondering how much coordination is being done with all these places I just mentioned, including yourselves. On a daily basis, do you do this weekly, yearly? I mean, I'm just curious.
Those are great questions. So actually, the White House initiated a project. It's called the Moonshot Project, and it's actually named after the exact thing that you just talked about. That's why he called it Moonshot Project. He said, we put a man on the moon. So the point is that they have now put funding towards doing exactly that. So that's one thing. It's called the Moonshot Project. The second is that this process of establishing cancer therapies, there is an enormous amount of benefit from quote-unquote centralization, and that's done in the NCI, the National Cancer Institute. They oversee every single penny that is spent in grants in the United States to be able to develop these things. There are 70 NCI-designated cancer centers. We're actually going through the process right now of being one. Those 70 institutions you asked, do they work together? The answer is yes. So as I'm the director of the Cancer Center at Loma Linda, we spend probably, without exaggeration, at least a third of our time interacting with other cancer centers. This work that I've described, you can't do this without interaction with other places because there are technologies that, so I gave you the example of the boron chemist. I mean, I wouldn't have even known about him if he, his cancer center director is the one that told me about him. They didn't have any real use for him where they were because they weren't developing BNCT. So there actually is a lot of collaboration between cancer centers, but there's not enough. And you are absolutely right. By the way, back in, I don't know if you know this or not, Richard Nixon is actually in 71 is the one who developed the National Cancer Institute. And he developed the Cancer Centers program. He quote-unquote declared war on cancer. At that time, there was absolutely nothing that was being done centrally. Absolutely nothing. Now, I would say, so I told you that about a third of our time is spent collaborating with other places. If you take into account not just the collaboration, but the reporting back and how funds are used, and there's actually a requirement from the NCI that you work with other places. You have to show that you've actually done that, not just say that you'll do it, you have to actually show that you did it. I would say that that probably is now up in the kind of 75 to 80% range of total dollars spent going through that type of process where it's across all of the centers in the country. So we're making progress, but you are absolutely right that it's not where it needs to be yet. But boy, I'll tell you, these things, you look back 10, 15 years, not even imaginable. And it's primarily because of collaboration between centers. You are absolutely right, but we're not there yet. We're not where we need to be yet.
Thank you. My brother was diagnosed with advanced prostate cancer. MD Anderson has him on an experimental drug, XTANDI.
Yes, understand.
Is your only facility in California? Because I know there are MD Anderson satellites that we've been to, but so Loma Linda, you're here, we're on the East Coast, that's on the West Coast. Do you have satellite offices, and how hard is it to get an appointment?
Great question. We do not have satellite offices. Although, after I've been here, someone asked me, we need a position in Beaufort, and I said, hey, we do not. We're not. MD Anderson has actually done the best job of creating satellite facilities in other places. You asked how easy to get in. I mean, that's something that as a cancer center director, it matters tremendously to me. So we have a single number for the cancer center at Loma Linda, because as a patient, you're not going to know who you should be talking to and that kind of thing. And so the people who answer that phone are trained to be able to kind of help figure that out. It's not perfect. I do what I call secret shopper calls, not telling them who I am and that kind of thing. We're not good on that yet, but the fact of having a kind of a centralized website and having a central number and letting somebody else do the work, is only they're going to understand how the local place works. Which person do you need to see first? What is going to be the sequencing of treatment? There's a lot of complications with that. Most cancer centers are taking that same type of approach, meaning you don't usually have to go and find your own program and put it together. They'll have a single entry site. But even that is complicated. Yeah, it's an important thing.
So I want to be, I want to cut us off because I want to make sure are there other questions? I want to make sure we have one more here, and then maybe I want to be considerate of time, and I'm not sure how much time you want to spend, but we'll be here as long as you want to, and then we just have some closing comments as usual.
Yeah, absolutely. And if after we get done formally, I mean, we can just talk informally also. You sound like you would have something to say.
I do. Ken, I want to apologize because I know him, and I can say, yes, you do need this microphone. Because I need it, and I have the loudest mouth on this island. My name is Celeste Nowaski. I'm on the committee, as well as Bill is our chair of the Government and Community Relations. And Tony, I want to thank you for bringing this to us because no one knew. Who would know? And the reason we need the mic is because it's being filmed. And the people who aren't here are going to be able to listen. So I'm an educator by profession. And I'm also a 30-year cancer survivor.
Congratulations.
And for 12 years, I led our local hospital has a foundation of the cancer.
Excellent.
And we raise funds. And it's pitiful what we raise, but we do it. So I am interested because when I had my mammography that saved my life 30 years ago, I did presentations for educators. And I said, I want one of my students who are going to be the recipients of this presentation to find another way to, besides squeezing you to death in the area where they had to do the mammography. If they had the same test for prostate cancer, there would be a cure by now. And they did figure it out finally, and I was here to see it, so I thank you. But I want you to know, I'm not in the, like my friend over there is in the industry. They're in the scientific field. How do we build this trust? Because you're coming to us, and I'm going to be going through the information. But the distrust in science right now is pitiful. And I don't want people to suffer because I lost too many in my family to cancer. And while they're doing this and trying to work together, we have people dying. So the human element is what I want you to present.
Those are points so important. Let me just, actually, one of the things that I thought of when you were talking about that, I actually, when I was in college, I had a chemistry teacher who really had a profound impact on me. That's why I went to graduate school, got a PhD, etc. Fast forward 20 years, he shows up in my clinic, and he has a giant, it's called a retroperitoneal sarcoma. It ended up taking a long time to take care of him, but he is now about 13 years out from that. He's alive. He was in really bad shape. He thought he was going to die. He had gone from being a vibrant, everyday runner and bicyclist and couldn't even hardly move. But he said something to me. He said, I now know why I spent so much time teaching the students well, because eventually it'll come back to be important to you. So, anyway, these are points of, and you know, the work that you've done to be able to you know, support cancer work. I mean, there are, if you think about how many millions of people around the world that are doing this, but it's never enough. But thank you for doing that. It is so important. And I like your comment about if you needed that kind of a test for prostate cancer, there would have been a cure already. Point well taken. All right.
Thank you, Dr. Reeves, and thank you everybody for coming. So I will, before you all leave, we will be around as long as you want us to be. Dr. Reeves will be here to answer questions. We'll just be hanging out as long as you, but I know some of you probably have other things that you want to do today. But we want to say thank you so much for joining us. We want to stay in touch with you as a resource, right? So we've given you some cards here. So just to give you some context, Loma Linda Health is in Southern California, as you probably know. We're an academic health science center, which means that we have a health system, we have a children's hospital, level 1 trauma center, specialist cancer center. We have an entire university that covers the entire range of health education from medical school, dental school, those types of things. And then we also have research. And so our approach to this is similar to what we do with everything we talked about, and I'm going to have Tony, who's going to give the last words here in a little bit. But Tony's experience was because we were the first hospital-based proton center. Infant heart transplant was one of the areas that we developed, longevity. And so we approach these things not just as a place to treat, but as a place to research, expand, and to grow. And that's really what we're focusing on now. That's why Dr. Reeves talks about the GMP lab, building out the theranostics. We're actually, because we have a school of pharmacy, we actually will be building out a radio pharmacy so that we can actually be doing and actually making the drugs and experimenting with them to kind of bypass big pharma. And so that's kind of approach. In fact, a couple of months ago, we just launched a big campaign because obviously the resources are needed to build that and expedite the infrastructure of that. But we would love to be a resource for you and communicate with you, and that could be a couple of different ways. If you have a specific question about cancer or some of the things that you talked about, you can go back and say, hey, I need to know more about that. If you just want to be connected and say, hey, where are the clinical trials, where can I get some of these, whether or not it's at Loma Linda or not, or whether you just like to stay in touch in terms of advancements and things that specifically Loma Linda is doing, or things that are happening in the field. And that could be everything from cancer to cancer-related things. We have this thing called lipid. I talked about longevity. We're one of the only blue zones we're the only blue zone in North America where we have the largest number of centenarians that live healthier, longer lives. In North America, there's 4 other places in the world. And that's largely based on our research. But part of that is understanding what are some of those cancer-preventing foods, right? So there's a variety of things that we would love to be able to share with you and communicate. So there's a couple of ways that you can stay in touch with us, and we'd love to. One of them, and I see many of you holding your cards. I saw some of you writing notes on the back of those cards, so we have extra if you need. But if you want to put your name, your address down there, we would love to stay in touch with you. There's a couple of check marks if you want to on how you want to be staying in touch, but we would be we'll connect with you and then figure out what's right for you and how you'd like to stay in touch. On that card, you'll notice there's no address and phone number, but on that card there's a QR code, and if you're familiar with QR codes, all you have to do is pull out your phone, put it on photo, aim it at the QR code, and it will have a link, and that link will take you to a website where it has our address and a phone number. If you're old school like me, I put my cards on that little stand over there. It has my cell phone, it has my contact information, address, everything. Please take that, use that as a resource, and connect with us, and then I can help kind of facilitate. The last thing, and probably the most important and most effective, is that you have Tony and Marion here. And so they know where we live. They know, most of them. And I would say they are phenomenal hosts. And we can't thank, can we give it up for Tony and Marion just as a thank you for really, just really good. I have never slept so well in my life. I don't even sleep that well at home. It was just incredible. So thank you so much. So anyway, we would love to stay in touch. And so if you can fill out those cards, Rochelle and I, or Dr. Reeves, if you can give it to you at the end, that would be fantastic. Thank you so much for your Southern hospitality. It is great to be back in the Southern region. And I'm going to call it home because y'all are wonderful. And thank you so much for this whole facility and the support for Dr. Reeves. So with that, Tony, I don't know if you have any closing comments that you want to say. Okay. And then we will just stay around. We're here as long as you need us to be and thoroughly enjoy. Thank you so much for the opportunity.
I don't know if we finished all the questions, but all I can say is that was above and beyond. I mean, it exceeded Dr. Reeves, all of my expectations. It was fabulous. I mean, I really think that was just super. I just had like one more question, and maybe it sort of comes back to how we coordinate a lot of this information. I think we're all bombarded with the new words, bifurcation and AI. How is artificial intelligence and getting a huge computer together going to affect the amount of consolidation of data, of information, all of the stuff that you're working on? And I think that's kind of like something that really can move this whole process a lot faster and a lot quicker.
Let me just say, literally, Tony, just one word, don't go away. AI is completely at the center of theranostics. You can't do it without that. Cell therapy also. So it's already the center of it.
Yeah. I always imagine, you go to a doctor and they ask you, tell me your background. And tell me, how did you have this, that, fill out this form, this form, this form, yeah, this, that, and the other thing. And just to be able to put all of this, all of your personal data into just one file, and to be able to have that open to any doctor, any place in the world, I think that's going to just make solutions easier and be able to direct you much more easier to the correct treatment. That's all. I don't have too much more to say. I can tell you some funny stories, and if you want to hear it, I'll tell you just how I came to Loma Linda. And I worked for Colgate in Europe for 30 years, and they used to send me to an annual, physical. The one thing I managed to postpone for a long, long time was a colonoscopy, because I had all of it. Wow, don't want to do that for a long time. So I thought, curing cancer was easier than a colonoscopy. But anyway, when I was diagnosed at the Mayo Clinic in Wiesbaden, some of my friends who are doctors sent me to the local hospital, Eppendorf Clinic in Hamburg, wonderful university hospital. And the most modern building was the building where the prostate center was located. So I went in there with all my diagnostics and I gave it to the doctor there. Dr. Uland was his name. And he didn't ask anything about me, how I felt, what was going on. He explained to me for 15 minutes how he built this building. And he said, next week I have a private room for you with great meals. And I said, wait a second. I said, what are the side effects? How about like potency and incontinence? Well, he says, we kind of like figured that out during surgery. I said, excuse me, do you mind if I get a second opinion? So I started doing research, and I went back to my urologist, and he said, I said, my daughter's out in California. I heard about Loma Linda. He said, yeah, might look into that. He said, that's a possibility. He said, we're going to be doing protons here in Germany starting next year at Magdeburg. And they did eventually start treating with protons there. But if you have cancer, you don't want to wait a year to see if maybe you can get injured. So I found out about Massachusetts General and Loma Linda. I went out to Loma Linda in June of 2008. And they said, well, we're all booked up until August 15th. If it's slow growing, don't worry about it. Just at 8 o'clock on August 15th, you can get into Loma Linda. Maybe. So I said, okay, well, let me go to Mass General. And as Dr. Reeves explained, they basically specialize in children, and they only do maybe 10 or 15 prostate cancers back at that point in time. And I was examined on August 14th, and I got to talking to the head international secretary there. I said, hey, you think I can use your fax machine to send my dad over to Loma Linda tomorrow morning at 11 o'clock, which is 8 o'clock California time? He said, sure. So I said, by the way, what does this cost in Massachusetts General? $225,000. Ooh, I said, okay, we'll see. So anyhow, I sent my data into Loma Linda. Oh yes, we'll accept you in October. What will it cost? $125,000. I say, okay, good. Saved $100 grand. Sent in both of my cost estimates to my German insurance company, and I didn't hear for a week. I called them up and I said, I'm sort of scared. I have cancer. How about an answer? He said, well, the person, in Europe, you get 6 weeks vacation and they take it. He said, well, the person on your file is on vacation. I said, maybe you want to speak to my lawyer instead of to me next time. So anyhow, I finally came back and they said, we'll give you $28,000 if you decide to go to Loma Linda. You can have surgery here, that's what it would cost under German medicine. And I said, well, okay. Called Loma Linda, must have gotten the right telephone number on that day. And the person said to me, I said, my insurance isn't going to really cover that. They said, well, if you pay $35,000, we'll treat you personally. I said, well, that's great. I said, and they said, just give us a credit card for $5,000 and you can pay the rest over 3 years. So I went out to Loma Linda. It was a radiation vacation. I took the treatment at 10 o'clock at night, and we played golf all day, went to the museums. I met so many friends out there. Really, it was just fun, and I'm not kidding. Non-invasive, it's like spectacular, and you can verify that. While I'm saying that, I've got to get this book out here. Now, keep it short. I will. And he fell down, and then it was the end of the surgery. So anyway, for the 2 or 3 months that I was doing treatments at Loma Linda, I was corresponding with my insurance company back in Germany, and I finally convinced them to reimburse me for the $35,000. They sent me a check in December 2008. I put it into Apple stock and made $150,000. True. And I paid off the other $30,000 in $300 payments. It was just like a really good story for persevering and really, trying to go after things. And the real problem then was really insurance trying to get approval, and it's still a problem in anything today. The last thing I want to tell you about, I left a few of these books by Bob Marchini. Randy, maybe you can explain a little bit more about Bob, the friendship we've had. Bob was a survivor of Loma Linda. He's written this book. You can be prostate cancer. You don't need surgery to do it. He takes you right through everything. It's funny. There's references in it. I've left 2 copies at the recreation center. I've left one, I think, at the tennis courts. I'll leave another one at the library. You can read it and just return it there. It's kind of like a little donation for me, not a big deal. But it is absolutely something you want to pass on to anybody who wants to find out about how to treat prostate cancer with protons. Randy, you want to say a few words about that? And I'm done. Thanks for listening to me. And thanks for coming. That's what all about, and that's the good deal.
Tony, you've done such a good job of sharing this. Bob, I'll just real quick. Bob is an engineer. He is very meticulous. Went through this and is really literally saved many lives, and is a great resource. And again, on that form, if anybody's interested in getting their own copy, happy to do that. Can you connect with Bob? Happy to do that as well. Resource. Thank you so much. We will be around. Again, if you can give your cards, if you fill them out, you want to stay in touch, to Rochelle, myself. My card is there by the door. Please take one. Happy to be a resource for you. Thank you so much, and we'll be around for as long as you want us to be to answer questions and just chat. So thank you so much.